data at this point. So whatever data we had in-house was the data we were going to use. We then develop and deploy a web application, a custom web application, and update the application with new data as new data came in every week. These were really critical, as you'll see in a second, that we did it ourselves rather than going out to bid or to ask an outside vendor. Some of the challenges that we saw in doing this was data presentation. So a lot of us here use data every day. We're not scared of a ton of data, especially those who use big data tools and R, Python, or other data visualization technologies. But to the average consumer, we didn't want to build something that was overwhelming. And we tend to do that, I would say, in both a planning and data community, of just kind of slamming lots of data out. But that doesn't really work for the public. So we really wanted to build visualizations that were inviting, but not overwhelming. We also want to design for all users, not just desktop users while we're developing, but also mobile users for those out and ADA users for those who don't necessarily have the same abilities as everyone else. Next, time to market. We couldn't wait 6 months to a year for an outside vendor or a technology consulting company to come and develop an application for us. We really had to get this application as soon as possible for obvious reasons. And we had to do it in a way which it was customizable if guidance from CDC or another public health agency provided different information, different guidance for us. And lastly, cybersecurity. We couldn't sacrifice cybersecurity while we were deploying these applications. We really needed to minimize and or reduce the risk exposure for us from a cybersecurity perspective. So some of the things that helped us in the beginning when we were going with this is that we already had a bunch of stuff laid out and was available for us. So we had a semi-centralized data storage. It's not perfect, but it's, I would argue, one of the most complete data warehouses or data lakes in the transit industry. We have a long history of data preservation, organization, and usage. From 2003 on, we've had a bunch of data minders that have helped us keep and maintain data over a long period of time. And we're constantly adapting to new technologies to enhance data usage from the cloud to Hive and Hadoop to really increase query speeds and to unlock more data for our analysts to use. And we have a lot of experience with continuous integration and continuous deployment of applications. We develop a lot of applications in-house, and we're able to really provide a lot of tools with a small staff. So some of the technical specifications, this is something that you can just take a screenshot of and send it to your application development folks or those who are trying to do this as a customized web application. It's hosted in AWS. We built it with JavaScript and Vue, which is a JavaScript framework, and the visualizations are done with Vega. That's a visualization framework, comes out of the University of Washington. And API and data files are exposed away from our internal system, so they're hosted completely in the cloud. So from our data standpoint, we take the bus data off our vehicles, we clean the data with our APC quality control tool, we migrate our data warehouse, we do a weekly extract and insert into our application automatically. So there's no one every week kind of doing the data mining and data preparation. So some of the features that we're able to bring out from this is our mobile-friendly infrastructure. So our application works completely on mobile and on desktop. On the right-hand side, you'll see our mobile-friendly interface with the shortened route names and trying to maximize as much real estate as possible. With the complete control over the application, we were able to really design for different types of folks. Some of the things that we learned along the way was that screen reader technologies are really heterogeneous in the industry. There's a lot of different ones for a lot of different folks. iOS does it differently than Windows, and really being able to design for all users was a really big challenge for us. And extensibility, our flexibility to add custom user interfaces, such as route sorting. You know, our routes don't sort alphabetically, as well as adding additional modules was really important to us. So we really wanted to be able to take this application, use it as our framework to allow us to add additional features like our forthcoming historic rail loading data and our real-time information data that we're trying to deploy as well. Ding. Thanks, Eric. And so this is sort of the desktop user interface. It works the same way at the URL below. So if you want to see how we're doing with crowding, you're welcome to come look at it. It's color-coded, and it also has tooltips, and it's also colorblind friendly, and it works really well with a lot of screen readers. It allows us to select routes and date types, schedule types, as well as see sort of an overall crowding pattern along a variety of routes. And with that, I will give the rest of my time back.
So we thought that would be useful to show folks, because it was focused on how to use historical data, and went into some detail and sort of the IT aspects of it. But you'll see a bit of an arc here in this session. Our next presenter is Charles Sanvito. He's a senior transportation solutions developer in information innovation technologies at the STM in Montreal. And he's going to show a little bit broader of how the data is used for different audiences. And want to sort of say it's very gracious of him to participate, because I think he was up all night in a workshop in Germany, participating in a workshop in Germany. So I don't think he's probably slept very much. So anyway, Charles, take it away.
Yes, my day started at 3 a.m. This morning, so it's a little bit late for me compared to you guys. But this is not a problem. It's the second day, so the jet lag is okay now. Yes, there's a little bit typo in my title. I'm a software architect, so I do not directly develop software, but I do the architectures of the systems. I have almost 15 years in public transportation in both private and public sector, and I'm responsible at the STM for almost all technology bus, all technology related bus to transit. So it starts from the embedded equipment on the bus to data analysis and passenger information. Let me just share my screen. So now you should be able to see my screen.
Good.
Yeah. So today we're going to talk about using automated data to monitor crowding levels at the STM. So the main topics we will go through, and it's very we will not go necessarily into details, but I would be happy to take any question further on if something has to be precise, or somebody is interested of go dive in more details into something. So we're going to start with the data flow, how the data is coming from buses to the different systems, the data interpretation and data quality that we achieve at the STM. We see the difference when we have different audience. We will do different data usage or data visualization. And at the end, we will talk briefly about what we do on the metro or the subway site too. So for the data flow, fortunately, at the STM, for passenger count or for crowding level, I'll start with the APC. So it starts with the automated passenger count, and then we have to take that information to the visualization to different audiences. At the STM, we are fortunately we have all buses are equipped with automated passenger counting equipment, so that can be acquired in both real time or when the vehicle arrives to the garage. So here's a little bit of architecture. When we can see on the top right corner the bus, and over the air, if it's distance, it's going to be over a 3G or cell phone, and when he's at the depot, it's through Wi-Fi. Everything is sent to the control center, and depending on where we want to see the information, it's transformed to the passenger information backend or into statistical databases. And on the passenger information side, then we can see on either for usually mobile apps or the website of the SEM, where we can see the crowding level. And on the statistical database, we use analytic tools to be able to visualize the data. Passengers are counted in each bus, and as I said, it's sent in real time, and data are processed. And statistical data is logged, so we can have a long period of time, whereas the passenger information is more real time. So after 5 or 10 seconds, all the data is refreshed. So how we process the data, raw passenger counts are accessible in the console center in a statistical database. So we can see exactly how many passenger the automated passenger counting system has count in the bus. This is 2, 3, 10, 11. The passenger information system translates raw crowds into crowding level. Which means that for in passenger, they will not see like there's 2 people, but it's really more a level that is more comprehensible for customer. But on the statistical side, we want to see the exact number. For statistics, as the EPC can do some errors. We always have some errors, like having negative number or passenger that are left on the bus at the end of the trip, at the trip end. Then in the statistical data, everything is clean and corrected when they are logged into the database, to make sure that the analyze will do, that we will do further on will be okay, which the things that we cannot do in real time. So for the different view, I split it in 4. First is the passenger. Passenger want to see the crowding level of incoming buses. So if they stand, or if they plan a trip or journey at a specific stop for a specific route, they want to see on that specific stop or what are the incoming buses and what are the crowding levels, so they can take a decision about if will they embark on that bus, wait for a second, take another line, another route. So it's really to help them to make good decision in term, more important now in the COVID situation, where if someone want to have his social distancing, then that information can enable them to do the right decision. The dispatcher, on the dispatcher side, he has all the number of passengers for each individual bus he is supervising. So he can take action if he send another bus on a certain route, or in case of disruptions, if you have to remove one bus, you can take the decision based on the overall crowding situation. On the daily scheduling, which means that day-to-day scheduling, or 1 or 2 days in advance, they actually look at the average passenger load per line at time of day based on usually the last week data. So looking at the last year data, especially in the COVID situation, is not that relevant. But looking at the last week data, they can see, they can have more insight on how they should adjust the services from a weekly or a daily basis. And for the booking scheduling, they look at the long-term data, usually per line, per day. They look at the maximum load point, etc. So it's for them, it's really important to have a large amount of data for a large amount of time. On the passenger information side, especially for in the COVID situation, for each bus, either have a 40-footer or a 60-footer, a standard, an articulate. or an articulate, the thresholds have to be defined based on the number and configuration of seats on that bus, and not necessarily say for any kind of bus 5% is one crowding level, and 40 is one is another, but it's really based. And even for a standard bus that usually like have 50 a capacity of 50 passengers, if I'm not mistaken. At some point on time when the STM received the buses, some seats configuration have changed, and some buses have a few have less seats than the others. So everything is really taken into account when computing or processing the crowding levels. So based on that, we look at the raw passenger count, and we compare to the configuration of seats on that specific bus to determine the crowding level. And as I note again, we define specific thresholds for the COVID situation, where when we say the bus is full, then it's a lot less than we used to say the bus is full last year. So for the crowding level, we indicate or we compute at the STM. We down it to 4. The first one is nearly empty, so meaning that distancing is possible. All other crowding level distancing is not possible because we cannot respect the 2 meters or 1 point, I can't remember meters distance between 2 passengers. For the second one is some seats available. Third is standing room only, and the fourth is nearly full. Sorry. Data quality. If someone is used to work with data coming from APC, he knows that no system is perfect, so it's not necessarily the data that we see is not necessarily exactly what it has occur in the bus. In real time, passenger count are corrected for negative value. So if the APC at some point say, okay, I have -2 person or -2 passengers in the bus, then we set it to 0. And we also set it to 0 at the trip end, because sometimes at the trip ends, the system say, okay, there's 5 person left on the bus, but we know that at trip end, everybody is supposed to get out of the bus, so we set it to 0. Statistical data are corrected and recalculate to achieve the a plus or minus 1 passenger discrepancy between each stop. At each stop between statistical data and reality, meaning that if at the end of the trip you say, okay, there's 5 people left on the bus, then there's some algorithm that will distribute that person where is more likely to have this person to disembark of the bus. Like if I have one event, where the door of the bus is open, but nobody is counted to get out of the bus, but there's 1 passenger at the end of the bus, there's the chance are that this is where it is missing. And we did do some field test where people are manually counting passengers that get in and get out of the bus to make sure that the system really achieve plus or minus 1 passenger discrepancy. Usually it's 95 or more % of the time. There's all sorts of other problem other than the EPC2. The EPC can be in problem, like the sensor can be not correctly calibrated. The STM, sorry, I didn't mention, but the STM is infrared technology. Driver can be unable to log on in the vehicle, meaning that the data cannot be associated to a line or to a vehicle. We have poor transmission quality, especially in real time. where there are zones where either the data, the cellular data is not available, or maybe the GPS is not correctly getting the information. And we can also have a lot of problem in scheduling data where the driver cannot select the correct trip or stuff like that. And a lot of data it's a little bit mixed up and can be unavailable in certain conditions. A quick view on what we show to our different audiences. So for the passenger, we just released the new visual for the bus crowding in our website, both mobile and desktop website. So passenger can consult information when they plan a trip. Yes, and real-time crowding levels are available only for buses, meaning I cannot see for particular stops like the or particular route that like they do at CDA. What are usually the crowding levels for that stop, or what would be my expected crowding level of my stop when my bus arrive? It's not possible yet. It's only the real time. So at the moment I see this is the crowding level, but when the bus has arrived on that stop, it could be a little bit different. On the dispatcher side, it's more a list, like a list of bus that say what is the number of seats and what is the occupancy. There's a lot more information as you can imagine. I simply put the morning Morton related to the crowding, and dispatcher has to do the maths for crowding level. So we have to figure out is 7/31 seats is acceptable or not. They have the definitions of the crowdings level based on the number of seats, but they have to do it manually. But it's a tool that helps them to see that, okay, I have an occupancy of 20. I can see like the fifth one or the sixth one, sorry, is 20/31 seats, meaning there's a lot of people on that bus compared to the others. Maybe I will send another bus to pick up people ahead of that bus to make sure that we make social distancing as much as possible. On the daily scheduling, as I say, it's more a day-to-day with a week to 1 week in advance planning for service adjustment. We produce graphics so we can see the difference passenger load, load or max load per line in a reports, or we can see how much overloaded trips we have based again on the COVID thresholds by the time of the day. So from day to day, we can see the evolution and do a service adjustment where is required. At the booking level, they gather a lot more data for a lot more time window. And they use that to try to forecast, which is currently a lot difficult because of the different regulation, to say, okay, on the next booking in 6 months, in 3 months, how it will looks like. So they use all the different approach and data to try to forecast that what would be the situation, and try to have the best plan schedules for the next booking. To finish a little bit on the metro side. So on the metro side, we are computing also the crowding. On the metro, it can be acquired in real time, as it takes 30 to 60 seconds delay to have the real-time data. We cannot go besides that. So what we do is not using that data in real time, because as you can imagine, between two subway stations. Sometimes there is less than 30 or 60 seconds for a metro to go from one to the other. So what we do is we apply some machine learning to try to forecast the crowding level based on both historical data and last value received. So based on that inputs, we generate what we expect to have as a crowding level for each individual, for each individual for each individual unit on the train. We also on our website show the historical data for the metro as the metro has more frequency. Is a lot easier than on the bus side to compute comprehensive statistical data. Usually on the metro side, we use 30-minute slots time. So for each 30 minutes, we compute the crowding levels. It's not, again, it's not a number, it's a crowding level, and it's also calculated based on the COVID thresholds and not the usual thresholds. For the bus and the metro, it's really, we achieved that only on the last 8 months in response to the COVID situation. It was not planned to have it on our website, either for bus or metro this year. I do not, I think that it wasn't neither planned for next year too. And one thing that we were lucky at the STM is at the beginning of the year, we complete on both bus and metro some implementation of the APC and softwares to be able to compute those information. If not, we would not be able to show it to our customers right now. And a little bit, let's say a last note for the metro. The metro is not counted as an APC, like counting each individual passenger, but it's based on the weight of the train as on the weight of the train divided by a number that I cannot say. I don't know if you use North American or European body size, but it's based on the number. So we average the number of passengers on the metro instead of counting each individual passenger. And it's the end for me. Merci.
Thank you, Charles. I think that showed a different approach than CTA. And now we'll have Logan Nash, who's in the Customer Technology Office at the Massachusetts Bay Transportation Authority, MBTA in Boston. And Logan, I think, is going to focus a little bit more on the customer interface, but I think it'd be a good complement to the other two presentations. So Logan?
You're on mute currently, Logan. Phrase of 2020.
Indeed, it's a problem of the time. Sorry about that. Yes, my name is Logan Nash. I'm with the MBTA in Boston. So we are the public transit agency for the Boston region, and specifically I'm part of the customer technology department. So as the name implies, we manage all the tools and the data that our riders use to navigate the system. So this ranges from our website, mbta.com, to the countdown signs you see in stations. We're deploying more and more signs, not just in subway stations, but also live digital signs at our bus stops, including e-ink signs. We also manage a lot of our operations-facing tools, our dispatch tools, since that's ultimately the source data for the information that we give to riders. So this includes our in-house mobile dispatch app, Skate, which I'll talk about in a little bit. Obviously what we're talking about here is real-time crowding information. And back in the early days of the pandemic, in sort of May and June, we became the largest transit agency in the US to publish real-time crowding information for local buses. Here's a little bit of what it looks like on some of our digital tools, like our website and our e-ink signs. And I think the thing I want to sort of dwell on here is the timeline, right? That if you had asked me back in February, hey, would we like to publish crowding information about our services to riders so they can see not just when their vehicle's arriving, but how busy it is, I'd say, yeah, sure, we'd like to do that someday. You know, we got a lot of fish to fry. But you know, April rolls around, the pandemic, everything changes, and suddenly this went from a yeah, nice to have farther down on the roadmap. So holy crap, we really got to look into this. And in pretty short order, in less than 3 months, we were able to get real-time crowding information out for some of our busiest bus routes, and able to expand from there. And that's sort of iterative development. This principle that Ray mentioned in his presentation is also something we're quite happy about and worked quite well here. And obviously the situation we were responding to here is the rapid drop in ridership in the pandemic, but also the uneven drop in ridership during the pandemic. So this is an index of ridership on all of our services, our bus routes, and then our subway routes, you know, color-coded green, blue, orange, red, et cetera. And the trend you'll see here is that while ridership declined drastically overall, it declined less on our buses, and quite a bit less, as it turns out. And so this informed sort of where we wanted to focus our attention, and we got really excited. Okay, this might be the moment for crowding information, right? But we really wanted to step back because even in the best of times, you know, folks like us, you know, data scientists, software engineers, technology folks, even in the best of times, we're not at all representative of the ridership of transit agencies, of the people that we serve. And especially during the pandemic, most of us aren't even taking transit at all anymore. You know, we're working from home, we're sitting in our offices. So we wanted to, before we really dug into deploying great new solutions for riders, make sure that we were understanding the needs of our riders during this really crazy, unprecedented time. You know, so normally what we would do, what we like to do at the MBTA is we'll go and talk to people, right? If we need to do user research, we will go onto platforms at bus stops, we'll talk to our riders, ask them questions. Obviously, that's not something that's safe to do during a pandemic, so we had to come up with different research methods. So we ended up putting out a survey across all of our digital screens and our website. We followed up on that survey with phone interviews and were able to do some remote sort of user testing, digital focus groups. This worked out well. And I want to mention this survey in particular because we got a really enormous response. So this was back in May, right? So I want to caveat the results I'll share there, but over 1,000 respondents. And when we look at the map of sort of what parts of the Boston area where people were responding from, we especially got a lot of responses in areas with a lot of you know, transit dependent riders, low income folks, historically disenfranchised communities, which is great because we know those are the people who are continuing to rely on transit right now. And you know, the responses we got from this survey were you know, kind of dispiriting in some ways, right? You know, the folks who are hopping on the bus or the train during the pandemic are doing so because they don't have other options, because they can't work from home, because they don't have a car. And they're putting, you know, they acknowledge that like, yeah, I'm putting myself at risk, I think, but I got to get to work. And it was also sort of a reminder for us that even if we had perfect information about crowding, you know, let's not pat ourselves on the back too much here, because we're still presenting our riders with sort of choices that are pretty crappy, right? You know, we asked folks, hey, what does it mean if we tell you that the bus that's coming is in 3 minutes is crowded? And, you know, some of the responses, like this one writer said, well, it means I have to decide between getting sick or getting fired from my hourly job. You know, it's not a great choice that we're presenting our riders with. And the other sort of useful, I think especially useful bit of information for us is that predictions were still the most important piece of information from a rider perspective, that people were interested in real-time and crowding information, but ultimately that information is not very useful if it's not presented in line with information about, hey, when is the bus actually going to come? And so this is why we steered away from building like, you know, special dashboards or things like that. We felt like it was very important to put the crowding information where riders are already looking, and where riders are looking is they're looking at arrival times and they're looking at schedules. And I think, you know, Ray and Charles talked about this, and I think it's a really important distinction to draw with this kind of work between real-time data and historical trends. And when we talk to riders about what kind of data they would find to be useful, definitely real-time data emerged as the winner here. That the historical trend, we had a hard time arriving at what the use case is there, because it sounds nice that we can, I think as transportation planners, with that kind of background, we get really excited about like flattening the peak, but for a writer, if you're like, hey, the time when the subway is least busy is actually at 1 PM, they're like, well, that's great, but I have to be at work by 9 AM, right? If you're an essential worker, that doesn't do a whole lot for you. So real-time data seemed to be the most actionable for writers. And I think the good news for us, and this was, more luck than anything else, is that bus, similar to Montreal, bus is the mode where getting real-time crowding information was going to be the easiest for us. And I won't, dwell on sort of, this presentation talks a bit about how like APC technology works. I think for this crowd, that's overkill. But I do want to talk a bit, like Charles did, about sort of the flow of how we got this information off of our real-time crowding information off of our buses. And similar to Montreal, most of our buses have automated passenger counters, had them all on there already. We never, I think maybe unlike Montreal, we never thought about these as a tool for real-time information, right? We installed them so we could do, more ridership reporting to the federal government and to our stakeholders and so on. So in pretty short order, we kind of had to hack together a way to take this information, never meant to be real time, and get it out there to riders, with minimal latency. And so ultimately, this data is coming from the APCs over our radio system to our dispatch system, which for us is Transit Master by Trapeze. And it lives in our dispatch database. And fortunately for us, we've actually gotten quite good at just strip mining data out of the our dispatch database. This is how we do develop a lot of our applications. So we were able to, rather than having to wait on a vendor to sort of develop the tools for us, we were able to do this using our in-house middleware application called Busloc. Does some of those transformation Charles was talking about, balancing at the ends of trips, correcting for just like wildly ridiculous data and things like that. And then from there, it goes out into our tools, into our public API, which is used by not only our applications like mbta.com, but also third-party apps like Transit App. It goes into our internal tools for our dispatchers, so again, similar to Montreal, and also to some email reports to help our garages sort of plan service. And the thing that was really could have been a stumbling block for us, but ended up being okay, was accuracy, right? This was such new information for us and for our riders, right? And it was in some ways safety information that we're telling people information about how safe it is to ride the bus. So accuracy was a high concern for us. And unfortunately, if you want to really validate how accurate information is, you've got to get eyes on the actual situation on the bus. So fortunately, most of our buses have security cameras on them, and it was a ton of work, but we had some awesome interns who were basically going in and for each and every bus route, validating how do our real-time estimates of passenger load line up with these manual counts taken via our security cameras. Again, arduous work, took a lot of time, but especially in the early stages of the pandemic, we felt like this was very important to us. And from a political perspective, important that we could, in sort of getting approval to push this information out from our management. And talking a bit about sort of categorizations, before the pandemic, there existed standards in the GTFS spec for occupancy data, standing room only, seats available, blah, blah, blah. We felt like these didn't really make much sense during the pandemic. So we decided to start from scratch and think about sort of go to riders and be like, okay, what categories actually make sense? And so we tested, we did some sort of digital focus group testing a few categories. Here's what we came up with. It's just 3 categories: not crowded, some crowding, and crowded. And what you'll notice about these categories is that they're very simple. And that's very deliberate, because what we knew about riders who are essential workers riding transit during the pandemic is they're more likely to be, low English proficiency, more likely to sort of not understand. I think our manage, as from sort of a cover our ASIS standpoint, we can get into like, oh, we want to use sort of very pandemic specific language, like likely at the limit of safe social distancing. But if English is not your first language, likely at the limit of safe social distancing doesn't really mean anything. So we wanted these to be short and simple. We used warning colors to sort of emphasize the data, and those same sort of people icons, our designers call them bowling pins, similar to what you saw in Chicago and in Montreal. And what was really great about this, I think, has been validating, is that we've seen other agencies, including Chicago, adopt, and Transit App, adopt these categories for their data as well. And this has been well received by our riders. So again, in June, we were able to get this data out there to our riders in a pretty short timeline. This is what it looks like on some of our rider-facing tools, e-ink signs on Transit App, and of course on mbta.com. I want to mention, sort of similar to the way Charles did, some of the internal uses of this data, which is a little bit less my department's realm, but one of the things we did very early on in the pandemic was we created these automated email reports, and in Splunk, which is our sort of cloud-based logging service, which was actually not even using APC data, but just logging instances where bus operators reported that a bus was full. So they just like pushed a button on their dispatch unit and said, hey, this bus is crowded. And this was information that we were able to package up and present to our garages, our dispatchers, so that they could sort of plan for service the next day in a responsive way. And this was great because we were able to get sort of the first version of the report out, which is just manual, like us doing SQL queries in March, very early in the pandemic. Then we were able to automate it and sort of make some iterative changes based on feedback from our operations staff, which is great. Another thing we did is we have an internal, an in-house mobile bus dispatching app, Skate. This is what our field bus operations staff use to manage service. And we were able to integrate our crowding information into that application, similar to what Charles said. Our operations staff can't always adjust service to respond to crowding, but we have heard from our staff that this does help them. They like being able to see what's going on in the street. They are sometimes able to make adjustments, and we felt it was important to give them this information. Similar to Montreal, we don't have the same kind of ability to give out real-time information on our subway system. So, with a caveat that we don't have a lot of faith in the value of historical crowding trends, we thought, if it's all we have on the subway, let's just do it. So back in September, we launched a sort of a historical crowding dashboard for our subway lines, again, available on mbta.com. And so where we are now is we've largely wrapped up this work on crowding. Real-time bus crowding data is available on all of our bus routes, except where there's been sort of technical issues getting in the way. We have the subway crowding trends available on mbta.com, and we're actually right now in the middle of sort of some retrospective research, going back out to some of the same riders we talked to back in May and saying, hey, how has this been working for you? Now that this is out there, that hopefully you've been using it, what could we do to make it better? And again, we want to be, because we're an in-house digital team, we have the ability to iterate and improve on this, and want to be doing that if we can. So I think one lesson, and I hope you sort of drew this from Charles's presentation, from Ray's presentation as well, is this kind of work was only possible in the time frame that all three agencies did it because of in-house staff, in-house digital talent. I mean, imagine trying to get a vendor, even the best vendor, to do this kind of work for you in a 3-month time frame. We'd still be waiting, at least with our vendors at the MBTA. So I'll end with that. I've got a lot of different folks in the MBTA help make this happen across many different departments. So I just wanted to sort of flag some of the staff who worked with me on this. And yeah, happy to take questions.
Oh, thank you, Logan. Well, 3 really interesting presentations. I think some questions have come in, but I'm going to throw out one just to start off with that I'm curious about. It's this transition from APC data that's traditionally used in an archived way for planning, planning after the fact, to transform it into real-time information. Most data is downloaded in the garage, APC data, and then quality assurance checked and so forth, and then it's used. Could both of you just discuss? It sounds like both had gotten to that point of already realizing that there was need to have a real-time information. There's some differences about the the validation that Logan talked about and so forth. But could you just describe how what was the biggest challenge in transforming, or what's your perspective on this whole issue of transforming archived APC data into real-time data that's available for apps for dispatchers? Charles, why don't you start, and then I'll get.
Okay. The biggest challenge is, I think it's always the biggest challenge at the STM is to make people internally adopt that approach. You know, that people say, oh, we have some quality data problem. I don't want to show it at customer if it's not perfect, and it's comprehensible that the people don't want to be thrown under the bus and to say, okay, the quality wasn't that good, but it's the fault of that team. So it's really more having to say, okay, and the fact that there's a COVID, I happen to see an image with is what is your biggest IT drivers, your CEO, your CIO, or COVID? And and you know, it's the COVID that takes everybody together and say, okay, you know, no matter what, the state of each individual department is on that approach. We have to come together with some sort of solution, some sort of data that we can give to our customer, because the most important is the safety of our customer. It's not if I'm comfortable on my seat right now. And usually it's the biggest challenge, but if there was not the COVID, people have tended to be able to don't know if I can say extend times, or we can have like more or less and put more or less stuff on that, but we don't have that. So we really focus right at the beginning to reassure internally the people if the quality was good enough, and we do it by doing a lot of analysis on the data. And at the end, everybody was comfortable by transforming the raw data to crowding levels, because you know it's something to have only a discrepancy, but when discrepancy is 1, 2, 3, 4 passenger, when you translate that to crowding level, it doesn't matter. Have we achieved 100% accuracy? Of course not. But is 90-95% accuracy is good? It seems to be good for everyone. Then we give all that we've got, and we will adjust, and we will improve as the day is going.
Logan?
I 100% agree with everything Charles said. It's like, I feel like we're living the same life here. I think we were preparing to have much more painful kind of conversations with our management about, like, you know, similar to maybe the conversations we had when we first released real-time data, right? Oh no, what if it's wrong? What if, you know, all this stuff. But I think COVID was, you know, for better or worse, allowed us to kind of fast track those conversations and get the data out there, which was great. I think the other thing is there's an element of luck to this, because for many agencies, including us to some degree, their infrastructure just doesn't allow them to capture data in real time, right? It's, you know, maybe their dispatch system is sort of too much of a black box, you know, or maybe it's not connected to their APCs. You know, I've talked to a lot of agencies who have those blockers, and unfortunately what you're sort of left with is, okay, well, I guess we've got to install new hardware on our vehicles is often the only solution, and that's, you know, hardware is hard, and that's frustrating. So I think we more, for us, there was more than a little luck involved too.
Yeah, it sounds like the crisis is always an opportunity, but I had wondered about that, because a lot of APC systems are not, they're only downloaded, you know, at the end of the day. So, Willem, do we have some questions?
Sure. Yeah. There was maybe a small follow-up, some clarification about whether you know, a lot of the processing happens on the bus or by the server in the control center, because now we're transmitting data in real time. So, you know, where does that kind of calculation take place? That's a quick answer.
Maybe Logan first.
Yeah, for us, that does not take place on the bus. It takes place in that sort of middleware application that actually, runs on a server, and its only job, not just crowding related, is to strip data out of our dispatch system and make it available in an open data format that other applications can use. So we want to do as little on the bus as possible, partly for vendor modularity reasons, right?
Charles?
At Montreal is depend on both on the onboard computer and at the control center. On the onboard computer is very small computation. Usually it's as I say, set it to 0 when it's not it's a negative number, or either for prepare for statistical analysis and say, okay, I count that person at that specific stop for that trip, which happen on board, and then it's fast track the analysis when it's downloaded to the garage. Whereas at some point is at the SM, and it's the same thing for other. We had to do the matching of the event, like a person shut it down and figure out where it's happened on the trip based on the number of times the door has opened, or when the door has opened, compare when the strip starts and stuff like that, which was really really more complicated on that day. Right now, it's really everything is embedded. So when we do a request, we know that it's exactly for that bus, for that line, it's going to for on that stuff.
Yeah, question from Amber, and I'm curious myself as well. Are you planning to sort of integrate, and you mentioned open data, Logan, sort of publishing this type of APC data along with other open data feeds and incorporating it into some of the sort of standards that are being developed?
So yeah, that was like a day one thing for us, is the real-time crowding data is part of our API and our GTFS real-time feed. So it's, it is it's the categories, right? We don't share the raw counts, partially because we don't have, like Charles was saying, we're not confident in the real-time raw counts. We're more confident in the categories. So yeah, that's part of our open data. I think the pandemic has spurred a lot of conversation around this existing GTFS real-time standard for occupancy data, which is really good. And this is something that we want to be available long-term. So hopefully, soon the pandemic can be in our rearview mirror. The MBTA wants to continue publishing real-time crowding data wherever we can.
Willem, is there another question?
Yeah, there was a question about from Zara, whether you've tried or been able to try and predict somewhat the number of people waiting at a stop based on some historical data. If there's sort of trips that occur regularly for commuters, if there's a way to predict that, there's likely to be a big group that boards the bus at stop A, and so, all the stops afterwards will see more crowding or not, or if that's been incorporated.
For us, no. And this was something we thought a lot about, both in terms of the data itself and presentation, is our data is not predictions, right? I think the way we display it, which is like, you'll see, hey, the bus arrives in 5 minutes, and you'll see a little crowding icon, might make it seem like, oh, the bus is going to be this crowded when it gets to you in 5 minutes, but that's not the way the data works. We'd certainly be interested in that, but it's just not something we're doing. Not something we're doing right now. Yeah.
At the STM, it's a two-part answer. The first is no. I mean, sure, for at the statistical analysis, they analyze that kind of stuff to make the shift stuff. Like if in the middle of a trip you have a subway station, then you know that a lot of people will either get out of the bus or get in on the bus, depends on the direction. So on analytics that point of view, yes. On a prediction point of view, we did not implement that yet because we have to prioritize our efforts, and as when we prioritized the efforts, we came to the situation where on the metro side, they would invest on machine learning because they do not have the real-time data, so they will have to do prediction. So we wait after they developed it so we can see how it could be applied on the bus side. So we will benefit of our first thing. Second thing, we thought that we can wait until we show the customers the first version and get their feedbacks before going forward with more data. Exactly like with the statistical data, we look at the statistical data for the buses and say, we don't think it's that relevant for customers, but sure, in the in few months or in few years, it's some things that it can be bounced between us with our and our customers to see in which direction they would prefer that we go.
Good. I have a quick question. You both had to spend a lot of effort validating the APC data, probably more so because people were internally, management was worried about the validity. Did you discover anything about the validity in terms that was a surprise in terms of where the weaknesses might be that you would not have discovered if you hadn't gone through those efforts? In other words, it was, you know, with the sensors or downloading or matching to scheduling data or whatever, was there anything that was, you know, the validity besides just sort of proving that it was good enough? Logan?
I think we were, and I'm not sure we fully unpacked this, but you know, we'd been using historical APC data for a long time. And so initially when we were trying to validate the accuracy of the real-time data, we sort of compared it to the historical APC data. And what we found actually was they didn't line up, and we were a little worried about that. But then when we compared it to the to sort of the manual counts taken via the security camera system, in a lot of cases we found that the real-time data was more accurate, which caused us to kind of revisit some of the corrections that are applied to the historical data. So I think it was, as always, it's good to sort of take a fresh look at these systems, and sometimes you find things you aren't expecting to find.
Oh, that's very interesting. Charles?
For us, as we take the last, let's say, 2 years to validate the statistical data, because it's I would use fairly new, but it's fairly new in terms of public transit agency, as our project started rolling out in 2015. But as a public transit operator, it's really new. In the last 2 years, we put a lot of effort in validating data and see how the raw data would be corrected to achieve the plus or +-1 discrepancy between the manual count survey that we did and the data we had in the what we say the corrected data. So we knew especially where the weaknesses were. So it's not like if we found like 5% of the trips that have a crowding of let's say a 300 passenger on that bus, I already knew that it could happen at some times. Putting in on the crowding level tends to smooth things up and say, okay, it's crowded. It's not 300, it's crowded. Maybe it's 15, maybe it's 16, but the APC said 300. What was interesting when we did that, it's more to discover maybe new way to use data. An example for validating or see what's happening, whereas we cannot either be on the bus and see the development website, or be on the development website at home and don't see the bus. We had to figure out new ways to get the data, present data internally. And one thing that was really interesting, because we get at point where we can have more insights of the data, even if it's not necessarily broadly used. We can have more insight data. I can rapidly compare real-time data for the overall fleet, per buses, the crowding level for the overall fleet. That the last year is not even something that we can imagine that we would do able to do right now.
Yeah. Okay, I think we're a little bit over, but it's been fascinating discussion. So I'd like to thank both Charles and Logan for their presentations, and we're going to break for 5-10 minutes and then come back on. So thank you all, and join us for the next session on research at TAL. Thank you. Bye.